Hello everyone, I am Emmet. I am going into my senior year in civil engineering with a specification in structural engineering. This previous year I was on the steel bridge team where we competed designing and fabricating and building a steel bridge you see before you. That is all of our team sitting on the bridge, which shows the strength of this bridge that only weighed about 60 pounds. I'm here to explain to you how to better compete in designing and building a steel bridge. So the first step is to set a schedule. Now setting deadlines is extremely important, as we discovered this past year, where we procrastinated a little too much and ended up not being able to fix fatal flaws of our design. In order to eliminate that, you can use software such as what you see before you in order to set deadlines and schedule and of when you need to have everything done by, such as designing should be done by the end of the fall semester so that you can start fabrication by the start of the spring semester. It's also very important to check and recheck the design, because it's, as you can see before you, it's much easier to use an eraser than a hammer. You can do this by using resources such as the AISC Steel Design Code and analysis software such as ANSYS. This is the ANSYS analysis of the bridge from last year, although it didn't fail here, but that is enough reason. Now, it is always crucial to plan for failure. As you can see, this is how our bridge failed last year, and had we planned for this to happen beforehand, we could have fixed this issue by bulking up this connection and allowing us to be extremely competitive with our extremely lightweight bridge at the regional competition. Now, to do this, you should test and retest the bridge. So first, you can test the design by using the analysis software I had previously stated, such as ANSYS. This will allow you to load a model that you have previously created and test it for failure and tell you the predicted deflection. Next, you can test the strength of the connections by using a universal tester, as you see before you, and applying a load until the connection begins to yield. This will give you the yielding strength of the connection and allow you to determine if the connection is strong enough for the bridge. Lastly, after you have finished completely fabricating the bridge, you should test it with the competition load in order to determine whether or not the bridge truly does meet the strengths required of the competition and if the deflection will be competitive. Next, after you've finally finished all of your fabrication and all of your testing, it is time to practice, practice, practice. In order to be competitive in the steel bridge competition, you need to reduce your build time of the bridge to between about 5 and 7 minutes. A lot of teams will only use 3 or 4 members to construct the bridge in that time. Those are the teams that will go to nationals, most likely. I'd like to wrap this up by extending out to the audience if they have any questions, or if you have any questions as a viewer on YouTube, you can just comment below and I will be sure to answer it as swiftly as I can. Thank you and have a good day.